Hello everybody, here's Mika, Simon, and we deliver this tech talk regarding data streaming and visualization in Lenses. This is a tool that we discovered actually when we joined Grid Dynamics, more or less 1.5 years ago. And we actually use it in our projects. And what surprised us is actually the accessibility of it. That is actually the best part that we want to show, and all way to access it.
So going through our presentation plan, first of all, we'll tell you what is Lenses and its purpose, at least according to their creators. And then we'll do an overview of the basic functionalities with some more advanced things you can do with it. And after the break, within part 2, we'll show you a live demo of our mocked analytics system that integrates with Lenses and multiple different streaming applications. So, what is Lenses and what is its purpose? By the definition from their creators, it's enterprise DataOps for Kafka, like very high-standing phrase. But yeah, it can be used for multiple different things like data management, visualization, especially infrastructure management, and with some built-in integrations. But that's why it can be used for. As an easy way for DevOps management, and that's not really why we want to show it to you, because we are big data developers, and that's not our main discipline. So.
Step back to the previous view. Let's imagine Lenses as something on top on your big data infrastructure. So it helps you to have an easy UI to integrate with your big data platform. It's not a big data platform itself. Lenses is a tool that actually allow you to access to all informations or all commands that you usually run from command line or from some shell script or Groovy script in case of DevOps. In this case, with Lenses, you have only, for example, one button or a text box, multi-choice that allow you to do it in a really easy and quick and fast way.
So what can you do and what can you see in Lenses? On top of the dashboard, and that's the dashboard from their out-of-the-box Docker image, you've got fully functional Kafka environment with broker, zookeeper, schema registry, Kafka Connect cluster, with overview of data within your, with amount of data within your infrastructure, and amount of running systems on top of it. You can access details of your services like specific hosts for Kafka brokers, CPU usage, disk usage, amount of topics stored on the current broker. The things that you actually would have to retrieve, the data about this you usually have to retrieve, as Simon said, with some command line or some external tools that are specifically designed purely for that. And that's something you get out of the box with a single Docker image that you can play around for things like prototyping or even simply learning the basics of streaming on top of it.
Yeah, as I said, it's on top. So think that you have to check what is the memory usage of your one broker or zookeeper, or even the connect clusters. That actually is what use the highest amount of memory. And sometimes you can have, 3, 4 clusters only for connecting, 3 clusters of schema registry, and the client come to you and say, I have some job that actually is broken. We cannot get this data. Usually you have to go on the command line and execute a lot of tasks that can give you maybe some information that sometimes are really hard to read. In this case, with one click, okay, the problem might be in Kafka brokers. So you click on Kafka brokers, you see all details and say, oh, I can see that the ID 101 or the ID 107 is broken, is with the red button, and at least you know which one is the node affected by the error. So our DevOps team or the infrastructure team can go directly there and see, okay, this is the error. And it's the same regarding metrics. You have CPU load, disk, how many records, how many space you have. In this case, you have already there. So you can actually think about like increase the space or change the hardware in case you have 80% of memory or 70% of CPU every time in iGload. So just for repeat, is everything accessed in one page, everything divided by tabs.
Okay, but as we said, it's not only that. What we mostly use it for is actually for things like actual data flow management and seeing and analysis of data in our applications and infrastructure. So the main page for that is topics page. I've seen other tools that allow you to do similar things, but those are tools designed purely for that purpose, and usually even didn't provide even at 1/10 of the capabilities of this one. You've got topic filtering, list of all the topics, amount of records, current throughput, data types, things like information about replication, consumers, partitions, and that's the overview. You can go into details. And then you got even more information. Like, first of all, you've got a data filter with on-the-fly SQL data filtering. You can do, you can write nearly any SQL statement with filtering with where options, joins, group bys, and get the results in human readable form. There are different options like table, preview. You can even download the data in raw format, whether it will be Avro or JSON. You can see the schemas, partitions, active consumers, configuration for the specific topic, which you can also change directly here. You can do things like live sampling of data or even manually insert messages directly into the topic, but it requires Avro, for which it will actually auto-generate the example messages. So we've got really powerful tool directly here on the topic preview page.
A nice integration or approach that we can have in this tab is, for example, for data analyst. You imagine that you have to do an extraction of data for your client and say, okay, I want to know how many views we got in 1 month, or how many views we have divided by, grouped by each minute from a specific endpoint. In this case, normally with Kafka, you have to create some application that Paul writes somewhere, and then you extract the file and go to the client. In this case, you can simply write a simple SQL query where you just extract what you need, click on the export button, and with that file, you can go direct to the client and say, okay, these are the data that you need, and maybe you can even like create a screenshot if the client has some access to the platform and say, if you want, next time you can do it for yourself directly. You can directly analyze which kind of data you have in a specific topic, how to manage this specific topic, or even, as Michal said, we provide already the data structure. Try to insert one data there and see how it behaves, how the topic is represented there, and how it goes through all processing things that we can have in our integration part.
Okay. Another part that is really important, especially when it comes to integration between different systems and platforms, is Schema Registry. This is a tool that, this is a platform that is responsible for validating the data structure with options like schema evolution and field schema evolution and schema validation. Here we can, I've seen actually the same solution from Confluent, that you've got this nearly exactly the same page where you can browse the schemas, see the schemas, but it doesn't allow you to create schemas and edit them on the fly. And that was actually surprising after working with Lenses, because here you can directly create new schema for your topic, edit it, and modify, and even see the history changes. Like here we've temporarily added a director to our movies field, like director field to our movies topic, and the schema was directly updated on the fly with mandatory default values, because the schema is actually enforcing the data validity. So old records that didn't have the new field required their own default, which is here is actually null. And then we removed this schema registry, actually realized that the previous schema is exactly the same, so it simply revoked the version, the current version to version 1. And yeah, like this is something that you can do on the fly directly through the UI. By default, you're doing that by registering with either your application or through Schema Registry API.
Yeah, the reason about first of all, I don't know if someone already works with Kafka and with Schema Registry in Confluent platform, but the important part of Schema Registry is that thanks to it, the data is always as we expect. Or when we decide to evolve the schema and the new field or new behavior on it, the previous data should not be deprecated. They should be still valid in order to continue to query it and to use it in our new processing phase. So this is why Schema Registry service continue to validate the schema every time you decide to apply new modifications on it.
Another part, which is the core of integration with any streaming platform that is based on Kafka, are the connectors. Here we've got a bunch of connectors. Like actually, there's no the scrolling goal for like 5 pages of connectors provided either by Lenses themselves or different open source providers. And you can use them to either sync data into outside of platform or read data into the platform. And what Lenses provides here is actually on-the-fly validation, where when you create the connector, it automatically tells you what are the mandatory fields for this specific connector. Those are things configured actually in Java classes that implement those connectors themselves. So here it says that we need to provide obviously name and some connection parameters for Cassandra, but depending on the different connector structures like JDBC, it may require like authorization for database or table names. And that's another thing you can do directly here. You can prepare, providing this, you can also either create a connector here directly, or you can export the query for like DevOps automated tasks. and they'll be generated as curl requests to Kafka Connect proxy. And that's actually another thing that Lenses provides single proxy for all the platforms, like for Kafka Connect, Schema Registry, their own API for streaming within single API. But actually, they just released some new API in Go language, but we didn't actually play around with it yet. And here you can just use some simple REST calls to perform all this in automated way. But previously we've shown you a bit of SQL engine in topics view. And when you say SQL, it comes with client's expectations. Like first thing that
this is my part, because actually we want to tell about the story that actually happened when we start to use Lenses. We went to the client and said, okay, please, what is this pipeline that we have to develop? I said, okay, we have to migrate several data from 5 or 6 databases, and after this, some particular aggregations, we have to store all the results in the new database. Say, oh, okay, show us what is the query that we have to do, what is the aggregation, the transformations, and then they arrive with really high expectations about streaming platform, because they say, okay, but in Oracle I can do it. I can do this huge query with 5 joins, aggregations, filtering, ordering. I say, yeah, okay, but now you are not talking about rows. You are not talking about tables and joins. You are streaming data. The first purpose of it is be fast. So when you get one row, you should see the result on the other side even before you finish to insert the data. And say, okay, so what can we do in this case? Use another tool or integrate the tool with something that it supports. Say, okay, okay, we don't like this tool. We don't want to use it. I say, oh, wait, I think you misunderstood what was the case of streaming platform. Then after a while, say, oh, but wow, this product is fantastic. You can insert the data and I can see already it in Oracle. Yes, because you stop think about 6 joins together or treat it as a job batch. So, okay, oh, maybe we should take some lessons about it. Yes, and after 2 days, they came again with another store procedure of 400 records. Only one.
Yeah, so what can you do with SQL queries? You can do things like simple left joins with like simple joins on either streams of data, or here actually we treat Kafka topics as actual K-tables underneath, which is more or less table representation of the topic. And on the fly, we enrich the views with client information, getting the results in a matter of seconds. But you can do, like, this is tool specifically for things like analytics access, like Simon mentioned previously, that you can export the data with some more or less complex query that serves the purpose of some set use case. But that's not all that you can do with LSQL. When it comes to this platform, what is really powerful here is it has separate streaming engine. You can create fully functional Kafka streaming applications that work as work as a representation of select statements on top of one topic and pushing data to another. You've got information about amount of processed messages, amount of messages sent. Here we've got example of filterings and group bys. So let's see how such processor actually looks like. You've got very simple statement. Actually, on top we've got few configurations for Kafka itself to tell it to automatically create the result topic, things like commit intervals for Kafka streams, partitions for the topic, replication factor. Here we set it for 1, mostly because the Docker platform that Lenses provides out of the box for developers comes with single broker, so that's the limit. But you can, in other environments, you can definitely change it. And what we do here, we just tell it to insert newest movies from the stream of movies where they're coming from the last decade. And that's all. Very simple, pure SQL statement. And we've got topology of stream with 1 filtering. And it's a matter of seconds until it starts processing, as you can see here, with the amount of messages processed. So there's another part of SQL, like of Lenses, that's really useful for especially prototyping or infrastructure and platform management. Here you can see the topology of the data flow we had for this specific information.
I can finish this. Okay. For Kafka, the main part is how to reuse all topics or processing results. The main part is to reuse always the same and aggregate and generate every time something that you need. Because one of the purpose of Kafka is write once, read several. So you can actually see what is in Lenses, what is present already, and then you can understand easily how to integrate all resources, all data that you already have, and process it in a different way. For example, with SQL Processor that Michal showed before. SQL Processor actually is the most important tool within Topology in Lenses, because you can write SQL, really simple SQL syntax for processing all data that you have in the topic, treating it as a normal row. So you have all information about data structure. So it's easy to visualize the data and also to processing through it. Topology simply allow you to see what is the result of what you think to do, because topology is just something representative. But in case of business analysis, you have the possibility to directly print this part even before the implementation and directly go to the client or to the analyst and say, this is what I need, find a way, and then our developers later, after the approval, after the discussion about, we will develop. So you don't need to develop before show the prototype. So what is the final result?
Yeah, and I just remembered something you mentioned when we were preparing to this presentation, actually, that you can think about this SQL processor as a Kafka or as a streaming application you didn't have to write. And I think it's really shows how you can think about it. And at the end, like last part we got here regarding the Lenses platform itself is platform governance utils. It's mostly related to things that DevOps guys may be interested, but it still can be very useful, especially for things like data access management. You can create some access restriction policies that are integrated with ACLs using some different data reduction ways. Here we've prepared the example of name policy that actually reducted name and surname field to initials. But there are out of the box, I think there are at least like 15 different policies that you can apply. One of the examples were like a card number reduction policy, where you only show first 4 digits, and then you can give them access to such platform to analytics team that can actually play around with production data without violating some access, like some policy restrictions to data access and private client information. Other things you can find here are like alerting rules, audit logs. Like, as you can see, before taking those screenshots, I've updated the schemas. Things like changes in infrastructure, configuration, some custom alerting systems. Yeah, there's multiple things you can do here, and they are used in an idea where Lenses works as a gateway to access your platform directly and manually. Yeah, and I think that's, for this part, I think that would be all from our side. And maybe you've got some quick questions already.
About the schema validation, when you define the schema, is it verified? Can you use it to verify the schema that's stored in the subject, or it is going to be as the new messages come into the subject?
I don't know if you understood correctly the question. You ask if the schema has been validated or the messages within the schema? Both. Okay. Who validates the schema is first Lenses at the first time that check if you are inserting a new field that is mandatory or not, and what is the impact that can have this modification on the actual schema version. Then there is Schema Registry behind that apply the Kafka part of validation. So in this case, Schema Registry check directly if can apply the schema that you passed in input to our actual data. So it's okay, let's try to apply this message. What happened? Now they insert and try a template, generated mock data. If they can still insert the message, it means that the schema is valid. Of course, you can apply different configurations of validity, and it's something that actually we didn't put on presentation because it's something more detailed that it's always not the best choice. You can change the schema compatibility version and how to manage the restrictions of it. Normally, you have default one that simply is, if it's nullable, you can add. Otherwise, we can check.
Yeah, like Simon mentioned, it's validated in Schema Registry, and it's actually, those are actually full functionalities of Schema Registry itself, not functionalities of Lenses, although it can work as a gateway between those. Because once again, it's something you usually do through REST proxy APIs, and that's how you do the configuration for it. But there's another side of it, and that's how actually Kafka works by itself, that you can always send a message to the topic, even if it has schema validation and everywhere. And it's on consumer side to decide whether this message is valid within the schema it's supposed to use. So yes, you can override this validation, but that's usually your fault. When you do this, you're usually done something wrong.
Hi, I have a few questions. I took a note actually, so sorry for that. Regarding the schema evolution, you explained it a bit, but let's imagine a situation, like for the audience, if they are not aware of that, let's imagine you have a table, which you call a topic. That topic had 5 columns. When you run the, let's say, the streaming, during the previous time, it actually inserted 5 columns. And then on, let's say, 2 weeks later, 3 new columns are added. So at this time, it would check like any of the streaming solution. It can be Kafka, it can be Pulsar, it can be Confluent. They would literally check that the new fields are nullable or not. If it's nullable, it would just insert. But when you talk about the history, like regarding the historization, so if you tell at the time that, okay, give me the history, let's say 5 weeks back, so how many columns it should return?
In this case, it will actually return the 8 columns because you define them as nullable. And it will retrieve the data it had with 5 columns previously, appending 3 null fields. And it will present the result alongside the rest of it.
Actually not. But yeah, yes, more or less. I mean, think that you have a producer, no, that is writing from or Pulsar or Kafka consumer, a producer. And you didn't apply the modification of the schema on your producer. So the producer is still sending 5 fields instead of 8. In this case, you can still produce these fields, and the processor itself, if you are not looking for the new fields, continue to processing it. This is why the validation is only for the previous messages. So at the end, if you insert in producer side, you continue to insert only expected fields. In the meantime, the processor check if those fields are mandatory or not. In case are not mandatory, they, as Michał said, store it as a null. Otherwise, we'll simply avoid them.
So is it possible to, let's say, give it some, let's say, some values? Let's say, if you give null, it doesn't look good, let's say, for a report, for anything, for a database perspective. So is it possible to give it some values like y, n, or let's say, it failed or something?
Yeah, you can define different default values, but even if you expect such behavior, you can modify your processor to handle those nullable fields and provide some static values if the set field is nullable. If that set field is null. Yeah, you can do that as a default in Avro directly too, yes.
What happens like in general, like when a topic is added? How do you feel? What happens like when a new topic is added? Because let's imagine for a Kafka or for a streaming solution, the topics are previously whitelisted. Zookeeper keep a list of them, and one of the zookeeper actually make one of the nodes as a master. And then if the master node fails, or let's say a new topic is added, is there a downtime in the system? Do you know about something called mirror maker failure? And that was, let's say, a very burning topic for the Kafka. How Lenses deals with that?
Actually, from Lenses perspective, the like any downtime on things like Zookeeper, Kafka brokers, is actually more like it doesn't affect the Lenses itself because the platform only stores configuration within Kafka. That's actually one of the features that allows it for easy version upgrades. But when you've got downtime of things like brokers, etc., it actually it's just running Java application that says, okay, I've got some connection issues. Here's what's down. It's just a reporting tool. You won't be able to probably access the data directly, but Lenses itself caches the state of the platform inside, refreshing it every so often. So let's say you've got an issue in broker, you don't have topic list, it's still stored within Lenses itself, but and it will get when the broker will be up again, then it will refresh the data itself. So the cache state will stay on the system, but on the dashboard page you'll have information. Yeah, those nodes are down, and that's probably more pending issue than not being able to access the topic list or data.
Yep. As I said at the beginning, think that Lenses is something on top of your infrastructure. Lenses is something that allow you to do everything that you usually do manually with an human easy access UI. So in case of failure on brokers or on Zookeeper or Schema Registry, first of all, you open the home page and you see this huge red button on your home page and say, okay, I think there is something bad. Then you have also one other part that is infrastructure we didn't touch, is about alerting manager. Lenses also provide directly out in the built-in solution alerting managers and metrics that actually are connected directly to Kafka metrics or other platform metrics.
When something is down, we have alerting. Yeah, actually, we have alerting rules by default out of the box. When any of those things are down, any node amongst them, you'll get alerts. It can be configured as any type of alerting, even SMS, if you're so crazy.
Of course, I suggest to put it in spam because otherwise your phone always, because we have this thing in our daily management.
Let's imagine a situation. You are monitoring your production environment, which contains, let's say, 90 or 100 Docker images, and they all contain separate application and separate infrastructure, which is running, and they are called as a services. And then you have a client and who are paying for those services. And those lists, when you give it to, let's say, a streaming solution, let's say Zookeeper, let's say, which comes with Kafka, or let's say any of the streaming solution which follows Kafka, you call it Pulsar or Kafka or Confluent, there is something called Zookeeper, which actually manages like which one would be the leader out of all the nodes when you run in the, let's say, production environment, which are multi-cluster environment, because there are multiple nodes. So out of, let's say, 5 or 6 nodes, there can be only one master, and rest of the 5 are follower. So you give it, let's say, when, let's say, you add a new topic, or you, let's say, add a new container. So what happened at that time, or let's say the master who is, let's say, leading everybody, okay, you do that one, you replicate that particular places, you do this calculation, you put this one, let's say, end of this log, and he actually manages everything. So the state between all these nodes, they are not, let's say, in sync all the time. So that was the issue for the mirror maker that I was talking about. And what was happening, that like when I was, let's say, adding a new topic, literally it used to have, let's say, a 10 seconds, not 10 seconds, it has a 32, let's say, retries that it can try to rebalance everything. So a new topic is added, a new partition is added, Zookeeper try to rebalance everything, and it has a 32 attempts that it can try, and then it fails. So this retry sometimes literally fails in production. So we literally had an outage of 10 minutes. So that outage has actually caused us around, let's say, a data gap of around 1 million record. So that kind of issue, do you see that, or how Lenses deals with this kind of issues, or like this kind of issues just comes as a out of box and like Lenses solve it like on wrap?
Yeah, like from my perspective, it's completely irrelevant from Lenses itself, because it's not the platform itself is mostly data visualization tool. And when it comes to management, you'll get things like alerting, but the infrastructure management side of it, it's still something you'll have to take care of yourself. Like you're saying things like you had a downtime of 10 minutes and million records of data loss. Well, it can happen, yes, definitely, and it's not the solution that, like, it's not an issue that Lenses is supposed to solve for you. So yeah, now I don't think you can use Lenses directly for that. Like,
it's more a matter of confidence, for example, in this case, not more a matter of Lenses, because actually Lenses showed you rebalancing informations, log informations, audit log informations, all this stuff, but remember that under Lenses there is always Confluent. So everything that is low level is always Confluent. You can apply for Community Edition, or you can apply for Enterprise Edition. Sometimes Lenses suggest to use directly Community one with different brokers or different zookeepers that actually are coordinated by Confluent platform. But in terms, for example, in brokers down or zookeepers that fail during rebalancing, we had issue on, for example, in one Confluent cluster that after several errors got down. We arrived to heap memory and got down. In this case, even before see it in UI, the alert manager engine that is on Lenses directly already notify you that there is something wrong that you will see soon, but you already be aware about.
If there is Kafka below or Confluent, you have KSQL in Kafka and here you have LSQL. Are these two languages related or are they communicating with each other?
Till version 2.3, no, simply not related at all. They parse your SQL and execute it as a Java Kafka Streams application. There is this engine behind Lenses that actually do this for you. From version 3, they are related, but LSQL also provides some functions more that then are changed in order to be compatible with KSQL as well.
Who was the first one? Who was the first one? Who invented this language first?
When it comes to language itself, LSQL is like 10 years old, but it was back then it was created purely as a language used for JDBC access to Kafka over Kafka topics. Like I may be overestimating, like maybe 8 years or so. When it comes to actual streaming language, I know that KSQL has been created first. And funny thing, I've actually seen like a week or two ago that Confluent is creating their own KSQL query language, which is literally the same thing that originally LSQL was.